All right, so we've written our test suite for pad array. We have our function ready to go. So let's figure out how to do this. Before I do anything else though, what is this thing right here? So we have 3 arguments, but one is set to null. What does that mean?
If we don't pass anything, it's gonna be default to null.
Exactly. So normally, if we just leave it like the usual way we've seen it, JavaScript is going to be expecting that when we call in this function, we're giving it 3 arguments in that order of an array, min, size, and value. And if we give it any less than that or more than that, it'll break. But if we do something like this, value equals null, we're saying, okay, here's what to do if we do not fill this one. We just saying value equals null.
You can set that to any default value you want, right?
Yes. So you can set this you can set that an argument to any default value you want. Value equals null. In this case, that's what we were told to do, so that's what we're going to do. What questions do you have about default arguments before we move on?
Is
okay.
Null like the common default?
So do you say null is like the default is what you said?
Is it?
It's one of the more common ones because I would probably just because null it is a representation of nothing, but it's a representation of nothing that we can work with. So if it was, like I said, if I just said we didn't give it an argument and it was expecting one, it'll break, but we say we're not getting an argument, we're getting null. So yeah, I would hesitate to say it is the default, but many programmers will use things like null, nil, none, whatever it's called in whatever programming language you're using, as often a default just so that there's something there. So let's pseudocode the solution out. So we have array, a min size, and an optional value. So what's our first step? Create a function pad. And optional value. All right, so quick question. One of the requirements of this is something we can just do right away, right? Because what happens if min size is less than or equal to the array's size?
You just return your array.
Exactly. So we can get that out of the way right away. So we can say if min size is less than or equal to array length, return array. We don't even need to do it. We don't need to do anything else. So that's one test case out of the way. What's the next step?
You could generate an array with the length of min size minus array.length and fill it with the value, default value.
So create an array of the length of the difference between them and fill it with the default value.
Correct.
Yeah. Okay, so we can do that. Create new array of length, array length minus min size, fill with, I don't know, I did with there, with value or null. Yes?
I kind of made it very simple, but after using the same array that was passed into the function to me. So I just took the array and and basically just add values to it if I need to, but I found there was no point of creating a new array.
All right, so Pavel has another way of doing it, which was adding values to the array. And how did you add the values to the array in this case to make sure you got it to the right length?
Well, the array that was given to me, I just got the size of it, and I compared the 2 sizes, the minimum size given. And if the minimum size given is larger than the current array, then I add value, and it's just a question of what value do I add. Or at least for me, that's how I do it.
All right, so adding values equal to the number, equal to that difference. So there's many different ways to do that. Let's do it the way that we were told earlier, just so we create that array. So once we have that array,
You would
what do
just
we do?
concatenate the array.
Yeah, so then we concatenate new array to array and return. Okay. So we created a function. Yes, we already did that step. So then we can say if min size, oops, gotta have parentheses, we're not in Python anymore, is less than or equal to array.length. Or I suppose if you need parentheses after length. I don't think you do. It's like the one JavaScript function you don't need to do that for. Then we just return array. Then we have create a new array of array length minus min size. So and that is filled with the value. So how do we create an array of that specific length?
So for me, I just put new space array capitalized.
Like that?
Yes, and then open parentheses.
Let's set that equal to a variable.
And then min size minus array.length. And then after the close parentheses, just put dot fill and then value.
Okay. So we by chaining these functions together, using new array, give it a length, and dot fill, we're just creating an array that is automatically filled with whatever we give it here, which in case will be either the value, which will either be what we give it, or null. So I'm getting oh, okay, that was some positivity. All right, cool. So our array, now we have two arrays, array and new array. And the last step is concatenate them and return them. So how can we concatenate these two arrays together?
So you could just do return space array dot concat, and then I believe you could just type in new array. That should work.
Let's try it out. So we do npm run test. Okay, so we had some failures, but that's good. Failure can be instructive. So what does it say? Expect receive dot to be expected, object is quality. Serializes to the same string. All right, so it's telling us what we should do here. So we have something that says if it should pass with deep equality, replace .2b with .2strict equal. So deep equality, that's a function. That's something I wasn't actually expecting to run into, but it's good that we did. So let's just do a Google search for that and see what happens. Deep equality in JavaScript. So these are NPM things. If we do it for jest, let's see exactly what they say. So we can actually look at exactly the function they were suggesting to see exactly what they say about it. What was that called? ToStrict equal. There it is. So use .toStrict equal to test objects of the same type as well as structure. Differences from two equal. Keys with undefined properties are checked, e.g. A undefined, B2 does not match B2 when using ToStrict equal. So it's a little more strict about what things are, so something with an undefined key would work. Array sparseness is checked, e.g. comma 1 does not match undefined 1. Object types are checked to be equal. So this isn't really telling us much about our exact thing here with just two arrays. But if they say we should use .toStrict equal, let's see what changes if we do. Let's just change one of them for now. All right, so by using .toStrictEqual, we had 2 failures and 1 passing test. So looks like, even though I'm not really entirely sure why they need us to do that, if it's just a one-dimensional array, if this is how they say it's got to be, it's easy enough to fix. Okay, there we go. All of our tests pass. So in this case, I'm not really sure why deep equality should work, but it looks like in Jest, to be safe, if you're comparing 2 arrays to one another or 2 data structures of any kind, .toStrictEqual is less likely to throw you an error. That's all I can tell you right now, because I've literally looked at, I've looked this thing over up and down, and I don't see any reason why it should do that. But if we're comparing arrays, that's what we do. And luckily enough, Jest was kind enough to tell us exactly where to look. So remember, even whenever you see those red lights, whenever you're passing tests or failing tests, don't panic, because more often than not, and this is why we use testing suites at all, is it'll tell you exactly what's wrong and how to fix it, possibly, and where to look. So if we had just used console.log and done some kind of equal stuff and gotten a bunch of falses but no explanation, we would just be lost. So whenever you see those red lights, I always take those opportunity to find out more about either about my code or about my testing software. All right, so what questions do you guys have about this solution and how it worked?
Question.
Yeah.
So 4 and 7, I mean, they're the same thing once the pseudocode of it. It says if minimum size is less than or equal to the array length.
Yes.
But I thought it said in the README that if the length is less than the minimum size. So it seems backwards to me.
Let's take a look. So if I look at the README for this,
Assume I'm just missing something simple.
if the minimum size is less than or equal to the length of the list, it should just return the list. So if my list is 3 elements long and they give me 3, it should return 1, 2, 3, and the same thing would be if I gave it 2 or 1. So it looks like, yeah, so it says if the minimum size is less than the array's length. So the idea of this function is we want to make sure that if we give it a minimum size, that the array has to be at least that big. So if the minimum size is less than how it is already, it's already hit that minimum size, so we don't have to worry about it.
No, right. I was reading the line right before the for example, the first for example. That's what I'm starting.
Okay.
Noah, I had a quick question. So I did this as a one-liner, and I'm not sure, like if I create a new array but I don't actually save it as a variable, does that actually take up space, any memory in the system?
So if you create something and don't save it to a variable, does it take up space?
Correct.
So as you said that, I realized I didn't do this, which I should have, but that's not answering your question. That was just something that came to me.
So
the short answer is yes, it still takes up space in memory, because what a variable is essentially a way of pointing to that place in memory for us so that we can do things with it. But that, even if we don't save something to a variable, it is still created. We just don't have a reference to it to actually interact with it in that way.
Okay, and then so my next question would be, if you concatenate it without actually saving it to a variable, does it actually get replaced?
So like as in, does the original array get changed?
Yes, without creating a second array. I think it would actually be easier if maybe we just pulled up my code and then I could probably kind of describe it.
No, I think I know what you're saying. So if we take a look at the concat method in its documentation,
okay,
that'll give us a clue. So we have the official MDN stuff. Let's look at W3 schools is usually more descriptive though. So concating them, We'll add one array to the end of the other. Let's see if it, there we go. So it's used to join 2 or more arrays. This method does not change the existing arrays, but returns a new array containing the values of the joined arrays. So this method, concat, is what's sometimes called a pure method because it doesn't change the original input value. It just creates a new output value based on what we give it.
Okay, so it's less efficient than just adding to the current array that you get passed in?
I wouldn't say that it's less efficient. And actually, most JavaScript experts would say that pure functions that don't change their input value are an ideal to be stripped. It's what we're kind of striving for, is we want to make sure that no function actually changes anything, it just repeats the output. I wouldn't really worry too much about, at this stage, about things like efficiency of changing something versus returning something new. The difference is, especially when it's just a function like this, is utterly negligible.
Okay, cool, thanks.
No problem.
Do you want to add a check so that they don't put a negative number for minimum size?
So do we want to add a check if we don't? It's to make sure they don't put a number for minimum size. So if they were to give us -1 as the minimum size, and our array was 3 characters long, what would happen if we kind of go through our function?
Would it not matter because it's just setting the new array anyway?
Yep. Yeah. So in this particular case, yeah. So other times when we're dealing with, okay, we want to make sure the length isn't set to -1. That would be the case, but in this case, we already have something that kind of does that, that says if it's less than or equal to the array, even if it's -1000, it doesn't make a difference. We still return the array. But other functions where a negative number could have an effect, then yes, we absolutely would want to do that. Is everyone feeling confident about pad array and ready to move on to the big one? Okay. So that would be balanced parentheses. So how do people feel about balanced parentheses?
It's pretty easy once you understand, what exactly the thing is looking for.
All right. So once you understand what it's looking for.
It drove me crazy.
All right. So
Balancing it for every case, like every possibility, like if it's top heavy, rear heavy.
So you're asking if it's possible, if we have to do it for every case, and essentially yes, we want to, ideally this function should return a balanced string regardless of how unbalanced it is. So we're just going to have to figure that out. And so let's take a look at this real quick. So I think I heard some people saying that one of the biggest hurdles was figuring out what we're actually trying to do. So all we have is a README in this case. They didn't even give us a Python or a JavaScript file. It says write an algorithm that takes in a string and returns a string with balanced parentheses only. The string will only contain letters, numbers, and parentheses, and that's it. So when we say balanced parentheses, what do they actually mean?
For every opening parenthesis, there's a closing.
Exactly. There should always be a match. Every opening parentheses should be matched with the closing parentheses. And they got to be in that order. So this one right here with an open parentheses and a closed parentheses is fine. But if we have them in the opposite order, it should just return a blank string. So it's interesting because if you look online for this problem, usually it's just returning a Boolean, is this balanced or not? But we're kind of taking this another step further and saying we want to return a string which only has these and rejects any that are unbalanced.
So we can do it in
Ordered dict. Why would ordered dict be helpful here?
because usually dictionaries aren't ordered. They're unordered in Python. But if you use ordered dict, then it will keep track of when it's added to the dictionary.
Mhm.
Return that out.
So return back what?
Return it back in the
Yeah. So could you expand a little bit on why using that and why you how you would use an ordered dictionary though exactly? Because
As if we're going from left to right, in our string, we can just order dict it into the order dict, and we can turn it out. We can manipulate it and we can turn it out.
Okay. All right. So we can use an ordered dictionary. That's one way of doing it. What other solution? What other if we're talking a larger concept, what other solutions do people have? Because there's a lot of different ways to do it. I'd like to hear some.
No, I have one.
Yeah.
So based on the results or the README file, the only thing you really care about in the end is whether or not it actually completes the parentheses, so everything else can be ignored. So what I did was just essentially go through and match all the open parentheses one way, and then if they don't match with another one, I just ignored them, and then I went from left to right, and then I went from right to left. So I think it'd be easier to show you what I was doing than explaining it, but
Okay. All right. So we may do that, is looking at people's solutions, because I think that might be helpful. Does anyone else have another way of looking at it they want to share?
Yeah, I did it slightly different. So basically, you create a list, right? And then if it's a letter, you just go ahead and append it to the list. But if it's an open bracket, you go ahead and push that index into a pointer array. And then when you come across a closing bracket, then you know it's closed. And then you could just pop it and then insert the open bracket wherever the pointer array pointed to.
All right. Using a pointer. Pavel, I saw your hand up earlier.
Yeah, I first went for every item with string to see if it's an open bracket that is before the first listed close bracket. And I just removed it because there should be no open brackets before the first close bracket. And then for the next step, I created an index of close brackets. And if the iterator was able to meet the open bracket after the close bracket, and the index would say that there's more close brackets.
Mm-hmm.
I confused myself with explaining this, but it works.
Mm-hmm. Yeah. All right. So as you can see, there's a lot of different ways to tackle this problem. So what I'm thinking is I might show you my solution, just so I can kind of show you that part, and then we can compare solutions as well. See, because I'm not sure if there is necessarily a best way or a wrong way to do that. So I'm going to do this in Python, I believe. So I'm going to call this balanced parentheses .py. In the interest of time, I'm not going to do I'm not going to do a spec file this time. Should be able to split it. Where'd it go? Editor layout. There we go. Just so we can take a look at both of the README and this. Gonna move this aside. Okay, cool. All right, so to do this, I'm going to be using I'm trying to figure out the best way to put this. So I'm going to be using arrays, but these arrays are going to be representing a different sort of data structure, and that structure is called a stack. Has anyone ever heard of a stack in a coding capacity?
Yes.
All right, what is a stack?
It's like a first in, last out.
Mm-hmm. Yeah. So think of a stack like a
Like I say, a deck of cards.
Yeah, a deck of cards is a good example. So when you put a deck of cards on a table, the only one you can draw is the top one. And that's the only place you can add things either. You can either add things to the top, and you can take them off the top, but you can't grab things from the bottom or add things to the bottom or the middle. Because what I'm going to be doing is I'm going to be checking, I'm going to be having two stacks here. I'm going to call one left stack. Do I have a indent problem? No, it's just being weird. Okay. I'm going to have right stack. And in other coding languages, stacks are kind of more codified into an exact thing. In this case, we're going to be using an array to fulfill the function of a stack. So they're still arrays. We're just treating them as stacks. That means we're only going to be dealing with the top, first in, last out, or last in, last out. All right, so what I'm going to be doing is I'm going to iterate through the string. I'm going to do the length of the string. And if it's a left parentheses, I'm going to add it to my left stack. If it's a right parentheses, it's going to be a little bit different. So let's just do it one step at a time. So I'm going to say if string strub string I. I'm just going to add it to the left stack. What I'm going to be adding actually is the index number, not the parentheses. Because what I want to do is I want to keep track of the index numbers of all of my parentheses, one way or the other. And I want to make sure that the left stack is balanced with the right stack. So every time I add something, every time I encounter a left parentheses, I'm going to add it to the left stack. If it's a right parentheses, one of two things is going to happen. Because if there's something in the left stack, that means they're paired. But it could also be, because we have kind of two cases to deal with when we're doing this, right? Either we have one here and one here. In that case, if that means they're paired because there's no other parentheses in between them. So we can just take off this one off the left stack because we know it's fine. We can just ignore them both. But if we have another case like, let's see, like this one right here, we hit this left parentheses, and we hit this left parentheses. So we have two there. So we're putting them both in the left stack. And then when we encounter the right one, then we can start peeling them off. It's kind of hard to visualize. So if it's one thing, we're going to say check the length of the left stack. And if there's something in the left stack equal to 1, then we're going to take so if there's something there, we're just going to remove it by using left stack dot pop. What does dot pop do? Yeah. Yeah. So it just removes the last element in the array, the last thing that got added. So if it has that means if there is a match, we just remove it. So we both know that these are fine. If there isn't a match, then we add this index number to the right stack. So by the end of this, we'll have two arrays. We're going to check. And the goal is, if they're balanced, then that means we don't have anything to worry about. What I mean to say is, sorry, I'm not this is something I figured like we did, and then I was like still trying to figure out in my head how to do it. So if any point I'm not making sense, please let me know.
So right now we're just checking.
Yeah. So when I say it's balanced, ideally that should mean is that if it's already balanced, there shouldn't be anything in the left stack or the right stack. Because every time we encounter a left parens, we put it into the left stack. And when we encounter a right one, either it has a match, meaning there's something in the left stack and we remove it from the left stack, or it doesn't have a match and therefore we add something to the right stack. So an unbalanced one would probably would have a lot of unmatched ones either in the left column or the right column. So, and since each of these columns are both filled with index numbers, that'll tell us exactly what we don't want to add to our final string.
So what you have so far is just checking if it's balanced.
Yeah, or yeah, at this, let me try something real quick. So I'm just going to say, let's see an example. Let's see if this will help us out with visualization. So I'm going to print out the left stack and the right stack, and I'm going to do some examples down here. So let's do one that's already balanced. Oh wait, no, that one's not balanced. This one should already be balanced. Wait, no, not that one either. All right, this one's already balanced.
I feel like balancing parentheses was a little ironic that we have to put these in parentheses.
Yeah. All right, so these two are balanced because they were both, we found one, added it to the left stack, then found the right one, added it to the right stack. And we didn't add it to the right stack because it had a pair. So we just removed it, removed this one from the left stack. Next time I do this, I'm definitely going to get an actual deck of cards because I think that'll be a good visualization metaphor. But then if I do one that's not balanced, like this one, what we should see is now there's something in the right stack because this right parentheses didn't have a match in the left parentheses. So, and then if we have another unbalanced one like this, our left stack is filled with these things that were never removed because nothing we didn't have any pairs in the right stack. So if it's already balanced, these should both be filled. If it's not balanced, we have arrays that have the index numbers of everything we need to reject. All right. Is this not making any sense at all right now? Or am I just talking nonsense? Feel free to tell me if I am. Okay. So for ease of kind of calculation, I'm just going to combine the two stacks into one because I don't want to check both of them. I just want to make sure that they are both there. Sorry. There we go. So I can just say final stack is equal to left stack plus right stack. So I could say, so if the length of the final stack is 0, that means we don't have to do anything and it's already done. So I could say if len of final stack is, oops. Then I can just return the string as it is. I don't need to do anything to it. But if there's anything in there at all, that means I need a new string without those index numbers. So I'm going to iterate over the string again. We'll say for j in range len of string. So those are the index numbers of the string again, and I'm going to say if j is not, oh, sorry, I forgot one thing as well. I'm going to have a return string called balance string. So I'm going to reconstruct the string here without everything that has one of those index numbers. So if j is not in the final stack, that means we can add it to our new string. Balanced string plus equals string j. And at the end of that, then we return our balanced string. All right. Yeah, it's a lot, right? Yes, of course. So in the else portion, we go over that. So I have an empty string called balance string. And I'm iterating over the original string the same way I did the first time. I said j represents the index number starting at 0 all the way to 1. Final stack is going to be a stack that has every index number of an unbalanced parentheses. So every index number in final stack is the position of something I don't want in this string. So as I go through each index number in the string, I check if it's one of those rejected index numbers. If it's not one of the rejected index numbers, I add that character to the balanced string. Any, like, what other questions do you have about how this worked? And we should also test it out to make sure it actually is doing what I said it's going to do. So I'm just going to copy this and add a few more examples. And I know this isn't real TDD, but I also, this is a lot and I want to make sure we've got time. So this one should be balanced already. And here's when it's unbalanced. Oh. Try that again. And let's also try this one. So if I run the file now, these are all balanced. This first one right here, so the very first one, this one, is blank because nothing in it was balanced, so we had to reject everything. The second one was already balanced, so it was just returned as is. This one right here, this last parentheses, we had to get rid of because it was unbalanced, and we did that here. And the last example, this one was unbalanced, and this one was unbalanced, so we got rid of both of them. All right. Does anyone think their solution was much better than this one? Because I wouldn't be surprised.
Working is working.
Working is working, that's true. But it's this is one of those things where there's so many different ways to tackle it, and some of them may be more efficient than this. So I do want to hear if other people's solutions.
Noah, would you be able to scroll up real quick, please?
Yeah. To here?
Yeah, I think I just used one loop as well. So I think that probably around the same efficiency.
Mm-hmm. Yeah. All right. Shall we look at a few? Does anyone want to volunteer to share the solution? Well, we only have 2 pull requests, so 3 actually.
You can try mine.
Yeah, I'll volunteer.
I'm sorry?
I'll volunteer if you guys want to take a look at it. It's the first one.
This one?
No, the first one that
Well,
was.
that's for pad array, right?
Oh, right. Oh, yeah, we're on the wrong one. Okay. Balance parentheses. There we are. Now you have 3 pull requests. So
Yeah, the Ian Robertson one.
there we go. Oh, so you did it in both Python and JavaScript. Good job. All right. So we take here, you have your input string. We have an input list, so a character for character in input string. So you created a list of all of the characters rather than keep them in a list. Is that right? Actually, Ian, do you want to walk us through this since this is your code?
Yeah, sure. All right, so we started off at the very top input list. Basically, I'm just going to take that string and convert it into an array so that we can actually use like an index to reference each character. Then the answer list is blank, and the pointer list is blank. So the pointer list is just going to store the index of the open parentheses. And then we go into the for loop. We're going to loop through the whole arrayified string, if that makes sense. And then if you have an open bracket, open parentheses, you're just going to append the index of that open parentheses, but you're not actually going to append it to what we're going to return. If that makes sense.
Yep.
But if it's just a character like A through Z, we're going to append that. And then once we actually get to a closed parentheses and our pointer length is greater than 0, we're just going to insert an open parentheses at the index specified in the pointer, the last element of pointer. And once we insert a open parentheses, then we just go ahead and remove that from the top of the stack.
All right. Yeah, this looks pretty good. One thing I would just say, but this is a very elegant solution. With strings in Python, you can iterate over them and use index numbers just like you would an array, as long as you're not assigning anything. So
I don't actually have to split it at the top?
Yeah, I don't think you need to split it. I think it would work just as well if you're iterating over the string directly.
Is that Python?
So Python specifically, you can't reassign characters in a string, but you can iterate over them using index numbers, and you can do that in most other coding languages as well. In some other coding languages, strings are mutable, meaning that once you have a string, you can change it. I believe JavaScript you can, and I know like other languages like Ruby you can as well, but Python strings are immutable, but you can iterate over them.
It's numbers that you can't, right?
You can't iterate over a number, no.
Unless you take it.
Yeah, so Steve just posted something here. I'm just like, so it's a Python visualizer. So this is actually really cool. So we can kind of, so.
I import a counter from collections because it makes an automatic dictionary for values.
Yeah, so this actually shows us like what things are at any given step in it. So you have a counter. So this website pythontutor.com/visualize.html is a very good tool. Yeah. So yeah, I completely forgot about this. Thank you. So we have char count here. Okay, thank you. So I can't really.
Yeah, it's a little junky.
Mm-hmm.
Just you can hit the very far left and very far right. It'll end up with
Cool. All right. Does anyone have any more solutions or questions they want to visit about this particular problem found in parentheses?
Yeah, Kevin actually had a really good solution. I was looking at his. Never thought about modeling it, the problem that way.
I don't think Kevin's here, so we can take a look.
You're making me blush, Ian.
Yeah, I'm not gonna lie. It took me a while because I had to like draw it out on a blank piece of paper.
So we have count temp result. So
yeah, so you start off by going from left to right and finding all the times that you have in a closed parentheses.
Mm-hmm.
So it keeps a count whenever there's an open one. And then if you find one but the count doesn't match, if the count equals 0, then they are matched. or else you'll decrement the count by 1, and then it'll add the character to the temporary string. And then you have to go back and you have to do it in the reverse order. So you have to, because after you go through the first for loop, you have all of the open parentheses left with the characters and the ones that matched for close. And you have to go back from right to left to be able to find all of the unmatched open parentheses, just using a string instead of using a stack.
All right.
Not good at explaining my thought process, but it makes sense in my head.
Hey, it makes sense. It makes sense. Yeah. So this is a great example of a problem that is, there's just no one right way to do it, but it's also one of those problems that'll come up. I once had a job interview where I had to whiteboard this problem. Not the most fun I've had, but it was definitely tough to do because I had never actually done this problem before. So now you've seen it before, which means that if someone asks you to whiteboard this, you'll have an idea of where to start at least.
There's different variations of this exact problem. So you might, like, you know, this one, but you'll encounter one that's similar to it, but not 100%.
Yeah. Or maybe parentheses and brackets and quotation marks. So.
This one always stops me.
Yeah.
Like I'll look at this and I'm on.
Yep. All right. So yeah, if at any point you just feel like you really want to like go over this in more detail, please come find me and we'll talk about it. And I can kind of go over the thought process in a little more detail when I have some more time to really kind of collect it. But otherwise, we're going to take a break, come back in 10 minutes, 10:01, and we'll start talking about not TDD, object-oriented programming. That's the word.